Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining again. So in this video, we are going to look at domain, range, and how to sketch it. So when we are done finding the range and the domain, how can we sketch the graph? So we have like 5 examples, and then I'm going to give you practice one to also work on it. So let's jump right in. So we want to plot this graph, right? Right here. But before we start, I want to give you something. So for ellipse, we are going to have the equation for a circle. So we know equation for a circle should be x squared plus y squared is equal to r squared. That's a circle, right? So now let's look at ellipse and then the others. So for ellipse is when the coefficient of x squared and y squared are not the same. So this is of the form x squared over x squared plus y squared over b squared is equal to 1. So now circle, I can have this. The first one is when the center is 0, 0. Now let's look at when the center is not 0. So I'm going to have this plus y minus b squared is equal to r squared. So this one too is when we have center 0, 0. Now here, so center 0, 0, and here we have center AB. Now let's look at when the center is not 0. So this is a plus h divided by a. This is squared, a squared plus y plus k squared divided by b squared is equal to 1. This is when the center is h and k. So what is going to happen here is, now I can write the first one as x over a all squared plus y over b all squared is equal to 1. And I can write the second one too as x plus h over a all squared plus y plus k over b all squared is equal to 1. So this is an equation for ellipse. So anytime we solve and we see that, so for example, this one that we are going to solve here, we see that x squared and y squared, the coefficients are not the same. So it means that we need to make sure that it is in the form of ellipse. Now let me add 1 to it, and then we now start working this. So let me add hyperbola to it. So for hyperbola is almost the same as the ellipse, but the only difference here is hyperbola is going to be x squared over a squared minus y squared over b squared is equal to 1. So it's going to follow the same trend. I can write this one as x over a all squared minus y over b all squared is equal to 1. That's when the center is 0, 0. And then, so please make sure you write this formulas somewhere so that you can refer to. And then we are going to have x plus h divided by a all squared minus y plus k divided by b all squared is equal to 1. So these are the three things that we are going to use in this course. So please make sure you write it down somewhere. So I'm going to erase it, and then we are going to go through our questions. So anytime you want to sketch, you are going to, for example, that we are going to have one of this, and then we are going to go through the process. Okay, so let me erase it and let's start our first plot. So anytime we want to plot, the first thing that we want to do is we want to look at the domain, and then we try to see if we can also find the range, and then we go through the process. So now let's look at domain first. So looking at the domain, we see that they've given us one domain here. X is less than y and also greater than 0. So we have one domain here, but we need to look at this. So here we need to make sure that it suits the ellipse. So let's see what we can do here. Now remember, we said ellipse should be x over a squared plus y over b squared, which is equal to 1. It can be less than or equal to 1. So greater than or equal to 1, or greater than 1, less than 1, any of them works out. So given x squared plus 2y squared less than or equal to 2, we want to make sure that this is equal to 1. That is what we are interested in. So what is here, we are going to divide through by what is here so that we get 1 here. So when I divide through by 2, I'm going to have x squared over 2 plus y squared over 1, because when I divide through by 2, I'm going to get 2 over 2, which is 1. But I want to have something like divided by. So that's why I'm maintaining the 1 here. And this is going to be less than or equal to 1. So what can I do? Now I can write this one as x divided by. Now I want to put all of them under the parentheses. But when I square this, when I expand it back, I'll have a squared. This is 2, but because I want to put all of them in a square, I need to do something to the 2 so that when I square it, I get 2. So the best way to do this is to find the square root of 2, right? So square root of 2 squared is going to give us the 2 here. So that's what you are going to get from there. And then plus 1 squared is the same as 1, so we can have this one as 1 divided by this, squared less than or equal to 1. So this is what we are going to get here. Now remember, this is an ellipse. So with the ellipse, we have something called this A, we call it the major axis or semi-major axis, any of them on the x direction. So the most important thing is that, okay, this is on the x-axis and this is on the y-axis. So A is the major axis and we can call B the minor axis. It depends on which one is the biggest, right? So A can be big enough or A can be greater than, so this one, let me call this one when A is greater than B, and when A is less than B, then A will be the minor axis and B will be the major axis. I think this one will differentiate it very well, right? And we can also call it the semi. So the semi, maybe we can give the semi to the hyperbola, right? So let's keep this one here. So looking at this, we can see that now, but don't forget we have this one here, right? Good. So here we can say that here we have the domain. The domain is an ellipse, right? Because we have an ellipse here. It's an ellipse with center 0, 0, because remember, we don't have minus plus h minus h there. So it's with center 0, 0. And we have a major axis on the x-axis because square root of 2 is 1 point something, so it's greater than that. So this on the x-axis, and we have the minor axis on the y-axis, which is 1. Good. So this is our domain, right? So let's try and sketch this. Can we find the range? Yes, of course we can find the range here, but let me see if we can play around this and see if we can get the range. If we don't get the range, then we can just go ahead and sketch. So let's play around this. I know that x squared is greater than 0, always greater than or equal to 0. I know that okay, let's just forget about the range, okay, and let's try and sketch this. So now we have the domain, which is also having x and y. So we have this one here. So what we can do here is we can look at this here, we can say that x is greater than 0 from this, right? And then we can also see that x is less than y. So x is less than y. Now, if x is greater than 0 and x is less than y, then this implies that y is also greater than 0, right? So that's what you are going to get. Now we want to sketch, so we want to use the inequality. So we can say that x is equal to 0, y is equal to x, and y is equal to 0. So this is what you are going to get. Now we are talking about ellipse. Ellipse is when we have a circle, let me say a radius of 1, and we try to stretch it. So when I try to stretch it horizontally, you will see that I'm going to have something like this. So it means I'm going to give more radius to the x-axis than the y-axis. And then if I stretch it vertically, I'm going to have it this way, and I'm going to get the ellipse. So that's basically how the ellipse is going to look like. So let's try and sketch this one. So I'm going to have my x-axis, but don't forget here we are saying that the x cannot be 0, right? And y2 cannot be 0, even though we are sketching x is equal to 0 and y is equal to 0. So x is equal to 0 is the y-axis, and then let me try and draw it well. Let me see if I can have dotted pencil. Okay, I don't have dotted pencil here, but I can have this one here. This will be my when x is equal to 0, and I can have my y2. This is y is equal to 0. Now let's look at how we are going to sketch the graph. So now we need to sketch the ellipse here. So the ellipse, we have 1, -1, and we have 1. But because square root of 1 is greater than this, we need to stretch this to this side and stretch this one to also this side. So our graph is going to look like this. Let me see. Let me just, are we including 1? Yeah, we are including the boundary. So we are going to have something like this. Something like this. Oh, my graph is not nice. Not at all. Let me try and then, no. I'll try my best to make sure that I have ellipse for you. Good. So this is basically what is going to happen here. This is basically what is going to happen here. But now don't forget, we have x is equal to y, right? Or y is equal to x. So x is equal to 0 is this one, y is equal to 0 is this one, and this is the ellipse that we've drawn here. So now let's draw y is equal to x. So y is equal to x is this. It's going to be this. Good. So this is what you are going to have. But let's look at what is coming to happen here. Now we know that x is greater than 0. So if x is greater than 0, then x can never be negative. So we are going to exclude the negative aspect, right? We are going to exclude the negative aspect here. And then we know that y is greater than 0. So we are also going to exclude the negative aspect. So it's going to be left with just the first quadrant here, right? This is the first quadrant which is going to be left. But since x is less than y, then it means that all coordinate of y is greater than x. So let's be here. Anytime I'm here, the x value is greater than y. So I need to be here. Anytime I'm here, you see, when I'm going up, I can pick like 8 and still I have it 1. I can pick like 20 and I have like 2. But when you are here, you can pick something like 20 here and you have y to be 1, which is not going to satisfy this. So it means that our graph is going to be in between this here. So this is where the graph is going to be like. This is where we are going to have our graph. So our graph here is, we're excluding this line. We're excluding this line. It's just this boundary which is inclusive. That's why you can see it blue nice there. So this will be the graph for our function. Very nice there. Okay, now let's try and then now look at the next question. So this is how the graph is going to look like. So we have an ellipse and we have all the dimension indicated nicely. Now let's look at question 2. Find the domain and range of the function and sketch. So now first let's go through the domain, right? So domain is always simple for us because if you look at domain, so this is going to be xy belonging to R2, given that since this one is square root, then what is under the square root, or what is under the square root should be greater than or equal to 0. So this is greater than or equal to 0. So simplify the domain and we have x belongs to R2, given that 16 is greater than or equal to x squared plus y squared, and this is the same as y belongs to R2, and here x squared plus y squared should be less than or equal to 16. Good. So this is what you are going to get for the domain. So let's try, and then let me write another step here. So y given to belonging to R2, given that x squared plus y squared is less than 16 is the same as 4 to the power 2. So if I want to sketch the graph for this, I'm going to have my x, I'm going to have something like this. So I'm going to have my y-axis, I'm going to have my x-axis, and this is going to be my graph with radius 4. So minus 4, 4, 4, minus 4. So this will be the domain if I'm just sketching the domain. Right. So this will be the domain here. Now let's try and add the range and see what we can do here. So this is the domain. Let's add range. So as we said, for us to find the range, since we have this function here, square root of 16 minus x squared minus y squared, this function should be greater than or equal to 0 because the square root is non-negative. So it means that this value is always going to give us 0 or positive value. So this is the first thing that we are going to get here. We are saying that we can make sure that we have 16, I factor minus out and have this, which is greater than or equal to 0. So now we set up this and see what is going to happen here. So as we said, since we are subtracting this from this and we don't want it to be negative, then the maximum value here is 16. It should be going up to 16. When we add this, we should be getting 16 here. So what is going to happen is if we set 16 is equal to 16, then when I subtract this one from the other side to have 16 minus x squared plus y squared, it's not going to be the same 16 again. They are not going to be the same, but they are going to be less than or equal to. Because if this is 1 and this is 1, I'm going to have 2, and 16 minus 2 is less than 16, which is great. So now let's form this. We have square root, so we can take the square root on both sides and have 16x squared plus y squared less than or equal to square root of 16. And this is going to give us, so this that we have here is f of x, y, which is less than or equal to square root of 16 is 4. And remember, we said f of x, y is greater than or equal to 0. So it means that this is greater than or equal to 0. So this is going to be the range. So our range is going to be from 0 to 4. So this is how the range is going to be. This is how the range is going to be. So don't forget, our domain here is a circle with center 0, 0 and radius of 4, right? And this is a disk because it's going to be inside because of less than or equal to. So that's basically what is going to happen here. But what is the range here? The range that we have here, this range here is a sphere with a center 0, 0, 0 and then a radius of 4. So that's basically what is going to happen here. But let's see what is going to happen, right? So this is what is going to happen here. Now remember, I said let this equal to this. So we are going to have, let f of x, y equal to z. So I'm going to have z to be equal to square root of 16 minus this minus y squared. When I square both sides, I'm going to have z squared is equal to 16 minus x squared plus minus y squared. Now let's move this to the right side. So this is going to give us x squared plus y squared plus z squared is equal to 16. And this is x squared plus y squared plus z squared, which is equal to 4 squared. So you see that this is basically, in a form of another circle. So even this is not an ellipse, this is a circle, right? But this is going to be sphere because we are going to three dimension, right? X, Y, space. So let's see how we can sketch this graph right here. Let's see how we can sketch this graph right here. So now we are going to be on X and Y plane. So I'm going to have my Z axis, I'm going to have my X axis, and I'm going to have my Y axis. So this is my Z, this is my X, and this is my Y. This is more interesting. Now, don't forget the domain is a circle with radius of 4, and the range is a sphere with also radius of 4. So on the axis, I'm going to have -4, I'm going to have 4, and I'm going to have 4. So now let me try and sketch the domain first. So if I want to sketch the domain, I'm going to have the domain to be this. So let me use red to sketch my domain first. So this will be my domain because my domain should be in the XY plane. Good. So this will be the domain. Then what is the sphere? This is where we have X, Y, Z, which is 4. So this is like radius of 4. So this is going to be something like this, going up here and coming down here. Good. So this is nice. So let me just make this one deep. Good. So I'm having a circle at the base. So this is the domain, and this is having this sphere here. Very, very nice here. So what did I do? Let me give you the summary. I just found the domain, which we can all do that. And then we also figured out the range. So the range started from here. We also figured out the range. We said since this is square root is always greater than or equal to 0, we set up our equation to find the range. And then since we want to check whether the function is a circle or not, we said, okay, let f of x, y, z be z, and it will be equal to the function that we have here. We take the square on both sides, and we had this one here. So this is the graph. Now, what is the name of this graph? This is the upper hemisphere. So this graph that we have here, we call it the upper hemisphere. So pay attention. Anytime you are working with maybe objective questions and you have something like fy is equal to something like 16 minus x squared y squared, you should be able to know that this is going to give us the upper hemisphere. This one can change to 4. If this is 4, still upper hemisphere, but our radius is going to be 2 when it is 4. When it is 9, our radius will change it to 3. So that is basically the idea with this beautiful question here. Let's look at question 3. Oh, nice. Now, question 3, we have the natural log function. But let me do something to simplify this. We know that a times b, because this is in the square brackets. It means that, and we can write this one as the natural log of a plus the natural log of b. Right, so it means that I can write f of xy to be as the natural log of 16 minus x squared minus y squared plus the natural log of x squared plus y squared minus 4. So I have two functions that I want to find the domain. So let's do that. Let me pick the first one. So the first one, the domain is going to be domain of the first one. So let me do it. Domain 1 of f is going to be x, y belongs to R2. Now here, remember we said with natural log function, when we pick what is inside the parentheses, it should be strictly greater than 0. So this is what we are going to get. We can simplify this and have xy belongs to R2, and then 16 is greater than x squared plus y squared, and this is going to be xy belongs to R2, and x squared plus y squared is less than 16, and 16 is the same as 4 squared, right? We can write 16 as 4 squared. Now let's do for domain 2. Domain 2 is going to be xy belongs to R2, given that, so domain 2 we are going to focus on here. This is x squared plus y squared minus 4, also strictly greater than 0. So this is going to simplify to xy belongs to R2, given that x squared plus y squared is strictly greater than 4, and 4 is the same as 2 squared. So let's combine the domain together. So now the final domain is xy belongs to R2, given that x squared plus y squared is less than 4 squared, and x squared plus y squared is greater than 2 squared. So this will be our domain. So let's sketch this. This is beautiful question because we have two circles with one being interior and one being exterior. So let's look at what is going to happen. So if I want to sketch this, I'm just going to say that x squared plus y squared is equal to 4 squared, and x squared plus y squared is equal to 2 squared. So both of them are a circle with center 0, 0, but the radius for this is 4 and radius for this is 2. So let's try and sketch that. So I have my x-axis, I have my y-axis. Now I have one circle, which is this. So let me try and then see. So I have one circle. This is not a circle. I have one circle, which is this. Let me try and erase what is inside. Good. So I have one circle. Let me assume that this one that I have here is the one with the radius 2. So I'm going to have radius minus 2, radius minus 2, 2, minus 2, 2. Now let me have another one on it. Let me have that one to be the one with radius of 4. So great. Let me erase what is inside and have this one to be the one with radius of 4. So this one is radius of 4. Let me change the color here. So this one is the one with the radius of 4, 4, minus 4, minus 4. Now how do we shade this? Now remember, the first one with the radius of 2 is greater than 2. So we should be going outside above 2, right? So that's basically what is going to happen here. We should be going above 2. And then the one with radius 4 should not exceed the 4. So the one should also be coming down this way. So it means that what is going to happen is we are going to shade here, but here we are not going to include the boundary. So when I finish, I'll make sure that I exclude the boundary. So this is how the graph is going to look like. It should be between 2 and 4, or the radius of 2 and 4. But here, we should not include the boundary. So we should be having something this. So let me try and see if I can exclude the boundary. Good. So this is the one with the radius 2, and then the black one here is the one with the radius 4, but we are trying to exclude the boundary. Great. So this is how our graph should look like here. So it's more interesting with working with this. All right, let's look at another one, which is our fourth example. This one too is much interesting. So let's find the domain first. So domain, okay, so let me just write all of them before we put them together. So the first one here with the square root of y, square root of y, it means that what is under the square root should be greater than or equal to 0. That's one. And then the other one to y minus x squared minus y squared should be greater than or equal to 0. So here 1 is greater than or equal to x squared plus y squared, and this is the same as x squared plus y squared being less than or equal to 1. So now we can put our domain together and have x, y belonging to R2, given that y is greater than 0 and x squared plus y squared is also less than or equal to 0. So this is what we are going to get. So now let's try and then figure out how we can sketch this graph. So what we can do is, since we want to sketch the graph, I will set y to be 0, to be equal to 0, and then x squared plus y squared to be equal to 1. So this is a circle with radius 1, and this is a line where y is equal to 0, which means we are on the x-axis. So let's try and then sketch this graph too and see what we are going to get. You can pause it and then sketch and see if you are going to get the same graph. So y is equal to 0 is going to be on the x-axis. So we are going to have this. That's the one that I'm using red line to write. So x is equal to 0, right? But this means that x is greater than or equal to 0 is included. So it means that my line should not be dotted line. It should be the deep one. Now we have a circle with radius 1. So I'm going to have a beautiful circle here with a radius of 1. So now let's see. This is radius 1. Radius 1. Oops, this one's supposed to be positive. 1, 1, minus 1, and 1. But remember, since y is equal to 0, like y is greater than or equal to 0, it means that y cannot be negative. So our graph is going to be above the x-axis. So it's going to be just the upper half of the graph. So this is what's going to happen. So this is the upper half, which includes the boundaries. So that will be the graph. So you see that it's not difficult. It's just, having time, practice more with questions. And when I finish, I'll give you some question here for you to also practice. Now let's go with this one too. Let's find the domain. On the top, y minus x should be greater than or equal to 0. We are including 0. Why? Because we are on the top. Right. Now let's look at the down. For us to find the domain, down y minus x squared shouldn't be equal to 0. So it means that 1 is never equal to x squared. Now when we take the square root on both sides, we are going to have, okay, this is the same as this, right? So when you take the square root, you are going to have x never equal to plus or minus 1. So x shouldn't be equal to minus 1, x shouldn't be equal to 1, right? So that will be our domain. So now let's try and write the domain out. This one too, we can write it as x is greater than or equal to, y is greater than or equal to x. So our domain is going to be x, y belonging to R2, given that y is greater than or equal to x is never minus 1, x is never 1, to make sure that our function is indeed. Now let's see if we can sketch this. So when we want to sketch, then now we can set x to be equal to y, and x is equal to minus 1, x is equal to 1. So let's sketch this. So I have my x-axis, I have my y-axis. Now, because x is never equal to 1 and minus 1, this is like a vertical asymptote. So we need to use a dotted line. So this is x equal to minus 1, and this is x is equal to 1. Now we have y is equal to x. So y is equal to x is the one which is going to pass through this here. But this one should be a straight line because this is included. But what is going to happen here is we are going to have a hole here, right? There will be a hole here because at this, the line cannot pass through. So there should be a hole here, which means that it doesn't touch the function. So the idea is that we are saying that x should be greater than 0. But when x is 1 and y is 1, for example, at this hole, since this line is x is equal to 1, it means that this is also minus 1 and this is also 1. So we are going to have a coordinate of 1, 1 and minus 1, minus 1. If we include it, we have a problem because when I plug in 1, 1 here, even though the top is going to be 0, but the down is going to be undefined. So it means that we need to exclude here and here from the graph. Now, where should we shade? Where is the graph heading towards? Now, since y is greater than or equal to x, it means that we need to pick the range where y is greater than or equal to x. So basically, it should be here, right? Because every value here will be greater than or equal to x. So it means that our graph is going to be here and moving up, just going up, just like that. So that will be the graph for this. I hope you are enjoying it. Let's finish it up. We have like 2 more and then we are done. Now let's look at this. I know we can now do this. So let's check whether this is a sphere or hyperbola. So let's see. First, domain y minus x squared minus y 9 squared, 9y squared should be greater than 0. That's the first thing that we need here. And then y, 9 is greater than x squared plus 9y squared. So now I can rewrite this one as x squared plus 9y squared, which is less than 9. Okay, so since this is positive, this is going to be an ellipse. But an ellipse makes sure that this is equal to 1. So let's divide through by 9. And we are going to have x squared divided by 9 plus 9 divided by 9 is 1. So it's going to be y squared over 1 less than or equal to 1. We want to write this one as x over a all squared plus y over b all squared is equal to 1. So, or less than 1 because of the way it is here. So it means that we can write this one as this. So since we are going to square it, we know that 9 can be written as 3 squared. So I can have 3 here and square it so that x squared, 3 squared is 9. And this is the same as y over 1 all squared is less than 1. So here the major axis is still on x because 3 is greater than 1. So major axis on the x-axis, right, which is equal to 3. So let me just shift this one small. It's equal to 3 on the x-axis, and the minor axis is equal to 1, which is on the y-axis. Good. So this is very simple and short to draw. So now let's just sketch this. When I finish, I'll give you a beautiful one for you to also try. So we have our x and y axis. So since this is stretching along on x-axis, we are going to have 3 here. We have 3 here. This is minus. We are going to have 1 here. We are going to have minus 1 here. So are we including 1? No, we are not including 1. So I'm just going to use a dotted line and then sketch something like this. And this is going to be the inner, right? Because of the way it is. Right. So this is what it's going to be. So just practice more examples and you'll be okay with this. Let's do this one too. I think this is the last one before your practice question comes in here. So let's do this last one. So did I state the domain? Yeah, so this is the domain. Yeah, this will be the domain. So you can write domain is equal to x, y belonging to R2 given this. Yeah, that will be the domain. So let's do this one too. 4x squared plus 9y squared minus 36 is greater than or equal to 0. So Now this means that 4x squared plus 9. Oops, this one too is still ellipse. I thought this is going to be hyperbola. Okay, maybe we'll get some practice question that we are going to get hyperbola on that. So since I want this one to be 1, I'm going to divide through by 36. So divide through by 36. So this over 36 plus 9 over 36 and less than or equal to 1. Now 4 goes to 36 how many times? This is going to be crazy. Okay, so I think it's supposed to be 9, right? 4 times 9 is 36, so that 4 times 10 will be 40, right? So this is going to be x squared over 9 plus, then 9 will go to 36, 4. So this is going to be y squared over 4, also greater than or equal to 1. So this is x over 3 all squared plus y over 2 all squared greater than or equal to 1. So it's basically the same thing like the first one that we just did. So domain R2, given that x over y squared plus y over 2 squared is greater than or equal to 1. But this one is going to change small, I think so. So we have our major axis to be 3, and we have our minor axis to be 2. So 2 will be here and minus 2 will be here. So this is going to be, so still we are going to include this, we need to include the boundary. Let me change the color. We are going to include the boundary, so I'm going to have something like this. My graphs are not nice. But here, they are greater than 1, so we are not going to go inside, but rather we go outside, right? But we are including the boundary, so this one is going to be like this. So this is like I, right? So this is what is going to be nice. So if I put some black small here, something black there, then you have your eyes, right? Good. All right, so this is the last one on the practice. So I'll leave you with this to also try. Make sure you try this. And because I cannot see the 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 graph, what you can do is you can go to, if you have subscribed to our channel, you have access to the community to post. So if you are done writing and sketching, you can take a picture and post it in the community that this is what you had, and we are going to also comment on that, because this one is going to be very difficult for you to submit it on the or in the comment section. So try it, solve it, and then post your picture in MerbsConnect community. See you in the next video.